Okay, let me ask you something. What if our entire approach to technology, I mean all of it, has been fundamentally flawed from the very beginning? Today, we're going to dive into a pretty radical new vision for our digital future. It's based on the work of Abhijeet Sarkar, and it's called the Synaptic ecosystem. And its core argument? Well, it's that the whole era of artificial intelligence is got to end.
And this quote right here, this just nails it, doesn't it? It gets right to the heart of the problem. I mean, think about it. We've built these incredibly powerful algorithms that can predict the stock market. But when it comes to something that really matters, like a global pandemic, they're basically useless until it's already too late. We haven't built true intelligence. What we've built are just really, really powerful calculators.
All right, so Section 1, the end of artificial. To really get what this new idea is all about, we've got to first take a hard look at the old one and figure out, where it all went wrong. So let's dive into the crisis of what we call AI today.
And this right here shows you the core difference. On one side, you have artificial, and think about what that word even means. Fake, extractive, just raw brute force. But on the other side, you've got synaptic, which is all about being more like a living thing, integrated, efficient, and always adapting. And I gotta stress, this isn't just about semantics or slapping on a new label. This is a complete fundamental shift in how we build things.
So let's break down why the current model is just, well, it's a dead end. First, you've got these cathedrals of heat. I love that term. We're talking about massive data centers that literally consume the same amount of energy as a small country. It's insane. Then there's data colonialism. Our every click, our every behavior is being mined for someone else's profit. And these black box algorithms, they're designed to manipulate us, not to empower us. And on top of all that, we're literally hitting a wall. The physical limits of what silicon chips can even do. Brute force just isn't going to cut it anymore.
Okay, Section 2, learning from biology. So, if building bigger, hotter, more power-hungry machines isn't the answer, then what is? Where do we look for inspiration? Well, it turns out the solution isn't about more brute force. It's about a smarter design inspired by the most incredible computer we've ever discovered.
Wow. Just let that sink in for a second. We are burning down the rainforest to print a map of the forest. This quote is just perfect. It so brilliantly captures the sheer absurdity of what we're doing right now. We're building these monstrously inefficient AI models that chew through unthinkable amounts of resources, basically destroying the real world just to create a digital copy of it. It's madness. There has to be a better way, right?
Let's put some numbers on this. 20 megawatts. That's not a small number. That's the absolutely massive amount of power that just one of these hyperscale data centers can burn through. These city-sized buildings packed to the gills with servers that run today's AI? We're talking about an industrial-scale furnace. Now, hold that number in your head, 20 megawatts. And look at this, 20 watts, not megawatts, watts. That is the shockingly tiny amount of energy it takes to run the single most powerful computer known to exist, the human brain. The difference here isn't just a gap, it's a canyon. It's an astronomical difference in efficiency. So, what's the secret? How is that even possible? Well, the problem goes all the way back to the 1940s. It's a fundamental design flaw in almost every computer we use, and it's called the von Neumann bottleneck. Here's the deal. In our computers, the part that thinks, the CPU, is physically separate from the part that remembers, the RAM. Imagine a chef who has to run to a pantry down the hall for every single ingredient. It's a massive waste of time and energy, and that's what our computers do. Almost all their energy is wasted just shuttling data back and forth in this constant traffic jam. But here's the beautiful part. Biology solved this problem billions of years ago with the synapse. In the brain, memory and processing happen in the exact same place. They're fused together. The chef is in the pantry. There's no separation, so there's no bottleneck. It's this incredibly elegant, integrated design that's the key to the brain's radical efficiency. And that is the blueprint for this new synaptic era of computing.
Okay, Section 3. You are not a user. Now, this is where it gets really interesting. We have this new blueprint for hardware, right? But this whole bio-inspired approach, it's not just about saving electricity. It completely changes our relationship with technology. It flips the script on who's in control. Because when computing is this efficient, it doesn't have to happen in some giant data center miles away. It can happen right here, on your own device, and that unlocks the door to true digital ownership, starting with the most important thing, your identity.
Because let's be honest, right now we're living in an age of data colonialism. Think about it. Your digital life, your identity, all of your data, it's not actually yours. It's owned and controlled by a handful of giant tech corporations. We're not homeowners in the digital world. We're just users. We're basically tenants renting a little plot of land in a world someone else built and controls completely.
Let me ask you a simple question. How do you prove you're over 21 without showing your driver's license? Without revealing your home address, your full name, your exact date of birth, all of that sensitive stuff, just to prove one little fact? The way we do it now is a huge privacy nightmare. But the magic of this new synaptic approach is something called a zero-knowledge proof. You can prove a fact is true without having to reveal any of the data behind it. It's a game changer.
And here's how it works. It's called self-sovereign identity, and it's actually pretty simple. Step 1, an issuer, let's say the government, gives you a signed digital credential, like a digital driver's license. Step 2, you store that credential securely in your own private vault, right there on your phone or your computer. Nobody else has the key. Then, step 3, when a verifier, like a website, needs to know your age, you don't send them the credential, you just show them a mathematical proof that you meet their requirement. The issuer and the verifier never talk to each other. You are the bridge. Your data never leaves your device. This is how we get an internet that we actually own. Okay, Section 4, Healing a Fragmented World. So once you have this foundation, this super efficient computing, and this idea of a self-sovereign identity, this is where things get really powerful. You can start to tackle some of the world's biggest, most complex problems. Let's just run through a few quick examples.
Imagine a pocket hospital. Seriously, using powerful, efficient AI tools like RuralDoc and ScanEasy that can run on a basic smartphone, you can bring high-quality medical diagnostics to the most remote corners of the planet. Suddenly, you don't have to choose between cost, access, and quality. You can have all three.
Or how about this? Credit for the invisible. There are literally billions of people who are completely locked out of the global financial system simply because they don't have a formal credit history. But with systems like Credit Vrishti, they can use data that they own and control to generate a trust score, finally giving them a key to access the economy.
And get this, the incorruptible auditor. You can use AI, something like G-Mintel, to analyze things like satellite data in real time to monitor government spending and big infrastructure projects. You can literally watch the money. It makes corruption mathematically, well, almost impossible. After all, you can't bribe a satellite.
All right, our final section, the call to build. Because everything we've talked about, all this amazing technology and these new ideas, it all leads up to one final and I think most important point. This isn't just a roadmap for new tech. It's a call to action.
This quote says it all, really. We are tired of being consumers of technology. We are tired of being users. The synaptic ecosystem is a call to become architects. It's a rejection of the idea that we should just passively accept the technology that's handed to us by a few giant companies. It's an invitation for all of us to stop being just users and to start being builders, to become the architects of a digital world that's actually fair and sustainable.
And so, that's where we'll leave it. With this final question, the technology, the silicon synapse, it's ready to go. And the need for a smarter, more efficient, more humane way of doing things, that biological imperative, is absolutely undeniable. The pieces are all on the table, so the only real question left is, what are we going to build?